Hello everyone and welcome to day 15. This is independent versus dependent events. So again, today is, believe it should be Monday on your calendar. And if you want to do a retake of the most recent quiz that we did, days 10 through 14, there is an option to do so. But in order to qualify for it, you have to have completed all of the past homework assignments. And you must reach out to one of us to let us know that you have a desire to take it so that we can assign it to you. And again, it will be located in today's folder. So moving forward, our warm-up here, this is a little review, we're gonna make a tree diagram showing the possible outcomes of flipping a coin twice. Okay, so we have the first flip, second, then our outcomes. For that first flip, you can either remember what are your two options when you're flipping a coin, heads or tails. If you flip heads first, you could get tails second, or you could get heads second. And that same goes for the tails. Again, this should be review. So I'm going to write out our outcomes. Heads, tails, heads, heads, tails, tails, and tails, heads. So now we're going to write out our sample space. I'm just going to draw an arrow because we did that with our outcomes up here. There's 4 outcomes. 4. And we're going to find the probability of each event. So our probability, this means that with the H, comma H, that means heads on your first flip and then heads on your second flip. So there's only one option up here that has heads on the first, heads on the second. So out of those 4, so we know there's 4 total, so that's our denominator, because remember our denominator is always what it's out of what the total is, that sample space is. And then there's only one option where you can get heads and heads. So that is 1/4. And if you want to write that as a decimal, 0.25. And then as a percentage, it's 25%, because if you move that decimal place over twice, you get 25%. Now, probability of getting a heads first, then tails second. There's only one up here. So that's again 1 out of how many total? 4. And again, that's going to be 0.25 or 25%. Now we're going to do probability of flipping a tail first, and then a head second. There's only 1. So again, 1/4. 0.25, 25%. Now lastly, probability of flipping a tails first and a tails second. That's here. So there's only one option, 1 out of 4. And I know by now you probably know that 1/4 is 0.25 or 25%. So they all have the same probability. Now moving forward, I'm going to be talking about independent and dependent. I'm just want to warn you ahead of time. You're going to hear the word independent and dependent quite a bit this unit. And the independent event is the probability of one event that does not, keyword does not, affect the probability of the next. So for example, if you're flipping a coin, remember how if you flip the heads on my first flip, your probability of flipping a heads on your second flip or flipping a tails is still that same percentage. So it's still 50%. And another keyword is you're going to see with replacement. I want you to identify always in all your problems. It's going to tell you if there's with replacement or without replacement. And if you see with replacement, know that is independent. So for instance, if you're drawing a card, if you picked out an ace of spades and you put that ace of spades back in your deck, you still have the same probability of drawing an ace of spades. And the same goes for marbles. This little thing down here says if A and B are, if they are independent, so if it qualifies under any of these, there's also more, but if you see keyword flipping like with replacement, then we know it is independent. Or rolling a die. Because there's a 1/6 chance of landing any of the given outcomes, and no matter how many times you roll it, that die is not changing. It's the same kind of situation as a coin. So probability of A and B, so A, or you could see this sign here, remember this stands for and, is probability of A times the probability of B. So this is what you do. You're going to want to make sure you have this written down as well. Now we're going to do some practice with it. So if you have a 6-sided die and you roll it twice, what is the probability of rolling a 5? Well, if there's we got to think of how many total outcomes there are. On a die, there's 6 sides, so there's 6 different options you can get. And how many sides have the number 5 on them? Just 1. Now, probability of rolling a 5 on your first roll, and then a 5 on your second roll. On your first roll, we just did that here. That was 1/6. And then your probability of getting a 5 on your second roll is also 1/6. Because if you were to flip a die again, it's not changing. Remember that key thing here that we had? Probability of A and B. Wait for this next problem here. This kind of means and, or it's that comma. So probability of getting a 5 and then a 5 again right after. Remember what we do? If they're independent, you multiply their two probabilities together here. So our probability of A was that first 5, and the probability of B was the second 5. Then you multiply them together, get 1/36. And that is your final answer. Now we're going to roll a die 3 times. So remember, if this little comma is meaning and when you have and they're independent, you're going to multiply. So what's the probability of the first 5? 1/6 times the probability, I'll just do 5 on the first flip, P5 second flip, P4 third flip. So that's also 1/6. And what's your probability of rolling a 4? That same 1/6, because you have an equally likely chance of rolling any number on the given die. I'm going to multiply that across, because that's what we do when we are multiplying, when we're finding the probability of independent events with and. That is 1/216. You can't reduce that because there's 1, you can't reduce 1 by anything. So next, now that we have independent, now we're going to see am I missing something? No, here we are. Perfect. So now let's identify if this is going to be independent or dependent. So if we're working in a turkey farm, one particular pen contains 5 white turkeys, 8 regular turkeys, and 2 gray turkeys. That's the key word here. If the turkeys are replaced, we're going to find these probabilities listed below. Remember how I said about if it's replaced? If they're being replaced, they are independent. So we know it's independent. And when we're solving probabilities that are independent, remember, you just this little comma here means and. So you're just going to multiply these two. So probability of a white turkey on the first one. How many white turkeys? Well, first let's figure out how many turkeys there are. So we got 5 white turkeys, 8 regular. That's going to be 13. And then plus the 2, so there's going to be 15 total turkeys. So our denominator is 15. And then how many white turkeys are there? There are 5. And then a probability of white turkey, our second, since it said with replacement, that means once you picked out that first white turkey, you were going to put it back. So that means since you're putting it back, there's still 15 turkeys. Then you will see, since you're putting it back, there's still 5 white turkeys, so it's still 5. So then, finally, remember that last step when you're solving probability of independent events, you're just going to multiply. So you have 5/15 times 5/15. That's going to be 25/225. And we're going to reduce that. Remember, we're going to always simplify your fractions. That's going to be simplified to 1/9, which is going to be, and then in decimal form, it's about 0.111 or close to 11%. But in a quiz or a homework quiz, it will tell you to either list it as a decimal, percentage, or fraction. So keep in mind with that. Now we're going to do the same process here because it is with replacement. Do that same process. Probability of a regular turkey, and there's 8 regular turkeys, so 8 out of 15, because there's 15 turkeys total. Probability of a gray turkey. Since we replaced it, there's still 15 turkeys, and there's 2 gray turkeys. Probability of regular turkey. Again, since we're with replacement, there is nothing changing about it. The probability is still the same. So then we have 8 fifteenths times 2 fifteenths times 8 fifteenths again. And that leaves us with 128 over 3,375. And that is going to be equal to 0.038 as a decimal, or about 3.8%. Remember, this is if they are replaced. If they weren't replaced, then it would have been dependent. That's the difference there.